Hello, and welcome to our first multi-business unit webinar within our monthly series. Today, we'll hear about how Amphenol Communications Solutions is enabling AI innovations from basics, high-speed connectors, high-speed cable assemblies, high-speed backplane, power solutions, and SSIO.
Good morning, everyone. My name is Angelo. I work for as a product line manager at Amphenol High Speed I/O Connectors. I'm going to talk to you guys about enabling AI innovations, particularly on our applications with high performance computing. So just explain a little bit more about HSIO connectors, SFP being small form pluggable. These are the highest rate connectors that we sell, and they come in a variety of shapes and forms. It's been a product for around 25 years or so, and ever since then, we've developed a very extensive portfolio, which you can see on the table here, each with its different size, footprints, and bandwidth capabilities. Currently, we are seeing huge adoption of the OSFP factor moving forward. And then for future generations, we are considering 448 gigabytes per lane, which means 3.2 terabits per second per port. So that previous slide was our core connectors. We also offer Overpass portfolio. Overpass is a flyover cable which links the I/O directly to the ASIC. So we offer three main components to this Overpass. Our Overpass products: the front I/O, the cable solution, and the near chip solutions. So the front I/O is very similar to our standard connectors. They sit on the front of the board and where they connect to other systems. We have our near chip products, which sit near the ASIC, and they come in a variety of packaging, such as the near package cabling and also the on package stuff, which is our osmium products here. So I'll speak a little bit more about the trends driving next generation HSO connectors. So why there's such a big need and why our portfolio has been developing is that there's faster and faster need for data rates. So this is especially important in these high performance computing applications such as AI. And in doing so, we will get into thermal management. So it's a balancing act between the thermal management and also point number four, channel loss budgets. So this is a fancy word of saying SI. So it's as we kind of crank out more and more data speed, we get more challenges with managing thermals as well as making sure our signals and frequencies aren't being compromised. In addition to those, the faster data rates, we're also requiring smaller and smaller footprints for higher density. This is very, very important because as computers, as more components get added and computer servers and stuff we develop and trays that we develop, they require smaller, smaller footprints so they can cram more stuff. So it's just a balancing act between all of these factors. Also, I would like us to talk about the power management. So as we get higher and higher channel losses with higher and higher speed, we're also requiring higher power usage for connectors. So we like to mitigate this as much as possible. But power budgets are the ones that are driving solutions that we want to see in for the future. So as I mentioned, our HSI connectors are quite diverse. They are used in a variety of applications, including the topic of today's webinar, data centers and high-performance computing and AI applications. They're also used in telecom and communications, as well as industrial applications. So in telecom communications, they're used in the front haul and the back haul uh, of the telecom architecture. So that's from the towers to the transmitting stations, etc. They're also used in industrial applications. So this is primarily the first point there, the test equipment. This is usually the test equipment that's testing the semiconductor production, the chip makers. They use our connectors for these devices. And increasingly so, we are seeing industrial switches, which use our high-speed connectors as well. But the main focus of today would be the data center. This is anywhere between servers, switches, top rack switches, or other computing such as GPUs, DPUs, and etc. We also sell emerging markets to or sell our products to emerging markets of storage systems, which is all interrelated in the data center. So speaking a little bit more about AI and ML applications in particular, this is a very good example or graphic about how um, all these components interact. And HSI connectors are used in um, every single component and every single block that we see on the screen right now. So that starts from the GPU with the GPU fabrics. So all these GPUs have to be able to connect and talk to each other, which is where we come in. We also see the network side. So this is the traditional switches, the traditional data center side. We've been a long standing partner with traditional switching, but this is going to be as GPUs and computing gets faster, we need faster and faster switches to catch up. And this is built in the same way and scaling up as the same way as the GPUs. And then, of course, we still need the PCIe to interact between the network cards and as well the GPUs, and we see our products in those as well. So, speaking a little bit more about how a typical compute tray is laid out, this is where our network tray or compute tray is usually laid out in here. So I also pointed to where our product would sit in here. So as you see in the red arrow here, you see that is a form of the front IO to a near chip solution that we sell. This is an integral part in the computing, high performance computing trays, and we're excited to make it happen. We also see traditional connectors in this application as well, so it doesn't have to be a flyover. And yeah, that kind of concludes our presentation.
Hello, everyone. My name is David Beal. I'm a product marketing manager for our Power Solutions group here at Amphenol. And today I'll be covering some of our different high power solutions that we have for enabling the next gen of AI. So with the AI trend in the global market today, the power needs and power consumption of the modern data center continue to increase drastically year over year. So here at the Power Solutions Group, we have invested and developed heavily our power dense products that help support this market. So I'll go over each one of these products in a little bit more detail in the upcoming slides, but I'd like to give an overview to start here. So our Cool Power HD is our latest pin and socket offering. So this comes in a cable to board or cable to cable configuration. It's highly configurable and has different latching options. So it's used mostly inside the box for server and GPU applications. Our PowerBlade Ultra HD Plus is our latest rendition of our PowerBlade series. So PowerBlade has been in the market now for over 20 years in data center applications. So this is our latest edition of that offering. It can be used as a board-to-board connector, cable-to-board, cable-to-cable, and is commonly found, again, inside the box or for a power supply application. Our bar clip BK1200 HD is our latest bar clip offering. So this is the bar clip connector that brings power into the different server and storage boxes inside of a data center rack. So this mates directly with the bus bar that runs down the spine of the rack. And this is our latest high density offering. And then we have our MCRPS standard connectors. Again, this is a pin and socket style connector that was driven by the OCP market. And then finally, we have our AC whip connectors that, again, are used to bring power in from the busway to the power shelf of the rack. And this was also driven by OCP standards. So first, I'll talk a little bit about our Cool Power HD. Again, this is our pin and socket solution that's used for GPUs and AI servers. With the power density increasing inside the box, we thought that this would be a very good connector series for those applications. We have a wide range of different pin diameters tooled, so it can support 50 amps per contact all the way up to 450 amps per contact and pretty much everything in between. So it's a power dense solution with a low impact footprint or a small form factor for PDUs inside server applications. And we have some different configurations. This can be customized to a degree, right? And we have different latching features that make it easy and reliable to connect these two solutions together. Next, we have our PowerBlade Ultra HD Plus. Again, this is the latest rendition of our PowerBlade series. So this one boasts up to 100 amps per contact, which again is very useful for power supply, BBU applications, inside the server, inside the storage box. It's kind of become commonplace, and the attractive feature about this style of bladed connector is that it's highly configurable. So you can add and remove the number of power and signal contacts that you need based on your power needs and based on the application's requirements. Next, we have our bar clip BK1200. Again, this is the latest rendition of our bar clip offering. So this is 1200 amps power plus 1200 amps return. And you'll notice on this bar clip style that the power density, again, is increasing year over year, but the footprint really has stayed the same. So in a 1 OU space for the OCP community, the power was getting too dense to terminate to a traditional wire. So you'll notice on this one we have a flexible braided copper termination on the other end of the bar clip. So you can just lug that directly into the PDU or wherever it needs to deliver the power inside the server or the GPU. Next, we have our MCRPS connectors. Again, this was driven by the OCP community. So this is just a different spin on our pin and socket style connectors. This actually takes power from the bus bar directly into the power supply for a server or a switch or a storage box inside the rack. So again, we're heavily involved in the OCP community. We like to partner with the customers in the OCP community, and that kind of helps drive our decision making and what products we continue to develop and invest in. And then lastly, we have our AC whip connectors. So these connectors actually bring power directly from the overhead busway in the data center down to the power shelf. So we have a saying in the Power BU to follow the power, right? So we have different connectors from the busway into the power shelf, and then for the bus bar, and then also for the different server and storage boxes inside the rack. So specifically for AC whip, we have a couple different iterations of this cable. We have a 30 amp, a 60 amp available in the market today. We're also developing a 100 amp pin solution, and eventually we're going to develop a 200 amp pin solution for the AC whip cables as well. And that just goes to show the ever increasing power needs of these different AI applications in the data center. And lastly, I'll mention there's many different standards, right, based on where you are globally. So there's IEC, there's NEMA, there's TUV, CSA ratings. So we've really done our due diligence to create multiple different configurations of the AC whip cables so that we can support all the different end customers globally with this solution. And that is all for the Power Solutions. Thank you, everyone.
Hi, everyone. My name is Jimmy Wang. I'm the product manager from Amphenol Basics. Today, I'm introducing our leakage detection cable product. The AI booming is coming with the era of liquid cooling. There are three types of cooling system for data center heat dissipation. Traditional way is air cooling by fan. But immersed liquid cooling is an option, but it's too expensive and not easy for maintenance. So currently, cold plate is the most popular way to cool server and switch. Therefore, sensor technology plays an important role in protecting precious properties against leakage. The working principle of this sensor cable is there is an electric path formed between electrodes 1 and 2. When the conductive liquid drops onto the cable, the 2 electrodes will be shorted. Then the resistance will be lower than the leakage is detected. We have 3 types of sensor cable. I call it type A, type B, and type C. Type A cable has the fluoropolymer carrier, which is the white color portion. And there are 2 black wires, sensing wires, wrapped around the fluoropolymer. When the water drops onto the cable, the 2 black sensing wires will be shorted. Type B is braided cable. It has the external braided insulation and 2 internal braided sensing wires. When the liquid drops onto the cable, liquid will ingress through the external and internal braided insulation, and the 2 electrodes will be shorted. Type C is FPC. it also has 2 electrodes. So the working principle is quite similar with type A and type B. This page shows the technical comparison between type A and B and C. Type A is more rigid, while type B is more flexible. And so type B can be wrapped around the cold plate. And type C is much thinner and wider. It has custom shape, so it can be used in those narrow spaces. Type A requires shorter dry time if the leakage happens. Type B needs longer dry time, and Type C also has a shorter dry time. For the corrosion and abrasion resistance, Type A is better and Type B is also good. But for Type C, because it's gold plating on the surface, so the corrosion performance is not very good. And Type A for the sensitivity, Type A is not as much better as Type B and Type C. But in the meantime, Type A has lower cost, while Type B and Type C has higher cost, relatively. For the wire-to-port connectors, we recommend to use our Minitech 1.5 millimeter or 2.0 millimeter. 2 poles is enough for common use. 4 poles is much better. Shorter the pin 1 and pin 4 for insertion detections. We recommend to use 30 micro-inch gold plating for better performance for the wire-to-port connectors. Okay, that is all. Thank you.
Hello, this is Greg Walls. I am the Director of Marketing for our high-speed I/O cables organization, and I'm going to be talking to you about how high-speed I/O cables are changing for the artificial intelligence market and how it's growing very quickly as the demands for artificial intelligence is driving I/O cables very strongly. At a high level, there's several major market trends going on with high-speed I/O cables today. One is definitely the artificial intelligence world. Another one I'm going to be talking about is the growth of active cables versus passive DAC cables. And the third one I'm going to talk about is the growth of I/O cables in the PCI Express application area. All three of these trends have been dramatically improving the amount of cables and the length of cables, and also the average sales price of these cables. So that is creating a great revenue opportunity for all of us who are involved in this market. In terms of AI, we all know what's going on there. You know, GPUs are becoming very important to artificial intelligence learning as well as inferencing. And these systems are magnifying the number of cables that are needed in every rack. So in the old days, it used to just be, in the old hyperscale data centers, it used to be an Ethernet connection between your top of the rack switch and your CPUs. Well, those connections still exist today, and in addition, there's other buses now that are going on that are being needed, and a lot of those are being connected with I/O cables. They could also be being connected with backplane cables or other kinds of internal cables, but also many systems are using I/O cables. Right now, those are mostly focused on putting 2 racks together, but they're going to be doing more and more racks as we move forward, and that's something that people are calling scale out. You'll hear that terminology, and that's where a lot of times I/O cables are especially needed. Especially when they're a little bit longer lengths, especially up to 7 meters. And that's where the second trend is very strong, and that is they're needing longer and longer cables as they put more of these racks together with not only the old stuff, you know, top of the rack switches, disaggregated memory and CPUs, but also adding GPUs into these racks. And that's where active cables come in. Active cables get us able to get us to higher or longer lengths, but they also allow us to get to higher data rates. And one of the things that you're going to be seeing with these GPU connections, whether they be to themselves or to the switches, is that they're going to be driving higher data rates for these so that they can do their learning, their artificial intelligence learning more quickly. And so they're really pushing the data rates up. And as they push the data rates up, the use of active cables is going to increase rather than DAC or passive cables. Lastly, PCI Express has come out of the board, and it's moving out of the box now, and it's moving into the rack. And the reason for that is PCI Express turns out to be a really strong low latency bus that is very high data transfer rates, and they're using this more and more to make these new kinds of connections between these different boxes. And so you'll see the PCI Express committee driving their data rates up, and they're also driving their links up, which means more active cables, which means a lot more revenue. And in fact, I kind of put a quick little chart on the bottom of here. If you guys are used to selling DAC cables, if you got twice as many networks and you're moving to higher and higher channel counts in every cable, like what's in OSFP XD versus OSFP or OSFP versus QSFP, and if you're moving to higher data rates, and if you're moving to linear active devices or active cables or DSP or CDR-based active cables, it really is a great revenue opportunity when all this comes to fruition and it all plays out. Now, we've made some references to some different kinds of cables. So we're all very familiar in the IO world with DAC cables, direct attached copper. They're passive cables. There's no chip in them. And so they use very little power. So they're very low power cables. They're very low cost cables. And unfortunately, they have the shortest reach. And in fact, as the data rates have been increasing from 25 gig up to now, we're at 224 gig lanes. We're seeing that the length of a passive cable is decreasing. It used to be 5 meters. Now it's down to about a meter to a meter and a half. So what has happened in the market is we've added these things called ACCs, which is active copper cables. And those products use redrivers in them or linear amplifiers. They use some power, not a lot of power. They do cost more. And the reach is definitely longer. And so it allows us for each of these data rates to extend the reach so that you can stay in the rack or connect two racks together is kind of what the goal is for most of the systems out there. Finally, there's the AEC, which is active electrical cables. They use a retimer rather than a redriver. They're either a DSP or a CDR. So a DSP is a digital signal processor. A CDR is a clock data recovery chip. They have the highest power of all these, the highest cost, and the longest reach. But again, it allows us to keep the copper cable in the rack or in two racks and not have to move to optics. We are working on another kind of cable called LPO cable, which is linear pluggable optics. And so an LPO, what that does is uses a redriver rather than a DSP, and we can achieve about 10-meter lengths. They're definitely more expensive than the AECs and the ACCs, but they can get a little bit longer length. And they give you, what's great about them is they give you not only the lower power than normal DSP-based optics cables, but they give you lower cost. And really important, they give you lower latency. And latency is very important for these new buses that are going in these racks. There's lots of other areas inside the PCI Express market for how they're utilizing these cables. You'll hear some terms, CXL memory pooling, storage applications, and then GPU clusters or CPU to GPU applications or network accelerators. All of these are kind of AI terms for these new buses that are being created where they need to have longer length PCI Express connections than has been traditional for PCI Express. They need more data rate, they need low latency, they need low cost, and they also need low power. And so all of these architectures are moving in that direction. In addition to PCI Express, though, there's other kinds of low latency buses that are being created these days. You'll hear all kinds of different terms. NVLink is one of them, and others. There's lots of different strategies out there, but a lot of them involve, kind of moving to new kinds of architectures beyond just the original kind of Ethernet architectures that most high-speed I/O cables have supported for years. Now, what's great about Amphenol is that we have the broadest range of products in the industry. We lead in all of these areas. This is a list of all of the major categories and the major lane data rates for each one of the different technologies. The ones that are marked in greens are the ones that we're introducing either this year or in the future, next year. So there's a lot of development work on speed going on. In addition, we also offer various active optical products. Some of them are LPOs, which is what I talked about earlier. That's kind of the new trend we think is the new trend in the market. We're going to see that coming out here in the next year or so. But you can kind of see we support all the standard interfaces. We work up to 224 gigabits now. We're introducing a lot of those products as we speak. We are developing 448 gig copper, so you won't have to move to optics for many of your I/O cable needs as you go to 448 gigs per channel. PCI Express is expanding, but also fast. It's not been as fast as growth, but we think there might be opportunities growing in that market also. And if no other reason, it's just because artificial intelligence is making the whole infrastructure just grow. The tide is coming in for the whole industry, and so we're seeing growth in those industries also. That are not necessarily AI, but they're just people need more storage, for instance, because of AI. Anyway, we serve all kinds of different markets. So the server market, the switch market, the storage market, the compute market. These are all growing markets because AI is lifting all these boats. In addition, we make custom solutions. So most of the stuff we sell through our distributors is generic Amphenol generic products, we call it, but we do offer custom solutions for larger applications. We've talked about all the different kinds of copper and optics, as well as some of these optics can get up to 100 meters. Some of them actually go much more than that, but the ones that are for artificial intelligence are usually under 100 meters. And then we are a vertically integrated organization, so we can offer excellent pricing, as well as we do our own bulk cable design. So that really helps us to give the exact right design for each of the different form factors. Lastly, I made a little chart here that kind of summarizes all these different form factors and data rates and speeds to kind of give you a quick reference guide. It's very helpful sometimes because sometimes these the terminologies get confusing. But I also put here the link to our website, and we've got a nice new solutions guide out there to help make it easy to pick one of the products that might be appropriate for your customers. We encourage all the distributors to use our website. There's lots of great information out there, and it can give you some ideas about maybe what you might want to carry in terms of your product line. So that's it. That's how we're using AI in high-speed I/O cables, and look forward to talking to you live with some questions later on.
Hi, everyone. Good morning and good afternoon. Thank you for joining. Today, I'll share a quick snapshot of how Amphenol's high-speed backplane connectors are enabling the growth of AI system, where they fit in the system architecture, and how our comprehensive products portfolio supports both current and the next generation AI infrastructure. Let's get started. The AI architectures are scaling at an incredible pace. In an earlier system, it typically uses 8 to 16 GPUs in one system, like the pictures at left side. Today, the leading platforms like NVIDIA GB200 system at scale up to 72 or even 144 GPUs. And in a future platform roadmap, there will be even over 500 GPUs within a single system. At this level, high-speed backplane connectors are essential. They provide the reliable high-speed bandwidth interconnections between GPUs to CPUs to switches. So in short, they are kind of backbone that allows the AI system to scale. Here are some system example here. First is the Meta Ground Teton system. Also, it uses NVIDIA HGX B300 system as an upgrade path. This is an OCP open source design that typically have 8 GPUs in one 4U system. Similar systems has been deployed across many data centers today. Here, at the front side, XMX connectors are used for PCIe Gen 5 channels, and it can be upgraded to XMX2 as the systems upgrade to PCIe Gen 6 speed. The second example here is the OAI 2.0 platform. Follow the OAM GPU standard. So any GPU vendors like NVIDIA or AMD, Intel, or even others can all produce a standard OAM GPU platform and put the GPU on this board. The extension board at the backside follows the MIDI interface of those extension board uses XMX2 connectors for high-speed channels. It's a 112G PAM4 channel. While the PCIe links at the front side is still use the same connector design as the NVIDIA HGX platform. So they use XMX connectors to transfer PCIe high-speed signal. The last example here is the NVIDIA GB200-300 system. These systems integrate 72 GPUs in one chassis. It uses Paladin HD2 connectors for NVLink signals, which is 224 gigabits signal speed. It's supported by hundreds of Amphenol high-speed twin-X cable from our CBS group. It connects all the computer chips and switch chips together. This architecture is already being deployed by most of the leading AI companies, including Meta, Microsoft, OpenAI, and also Amazon. This is the product roadmap from HSB PBU. Amphenol offers the broadest connector portfolio in the industry, scaling not only on performance, but also for density requirement. In this roadmap, the vertical direction is the speed performance of the connector, and the horizontal direction is the density of the solution. The AirMax connector here is the most cost-effective backplane connectors that can support up to PCIe Gen 4 speed rate. Exceed HD family here is widely used in storage system where it requires a very high density connection. XMX2 connectors has become the industry standard solution for PCIe Gen 5, Gen 6. It also supports 112G Ethernet applications. One new product here we just released this year is called HD Express. It is a high-density version PCIe Gen 6 solution for solving increasing density requirements for data center. It is a great alternative to the standard card-edge connectors when higher density is required. Paladin HD and the Paladin HD2 connectors are the world's leading backplane connectors for 224 performance. It is a go-to solution for any customer when they are working on a 224 system. It is actually the only connector solution that has started high volume production for 224 speed. One new product I would like to introduce is called ZenaMax, which we will release in later this year. It's our next generation backplane solution targeting PCIe Gen 7 or 300 gigabits speed. Together, all those families provide the performance, density, and also scalability across all AI architectures. So to summary, AI systems are rapidly scaling from 8 GPUs to hundreds in a single chassis. So high-speed backplane connectors are the enabler of this scale. Amphenol delivers the most comprehensive connector portfolio from XMX to Paladin HD2, ensuring the performance today and also a clear path to the future. With global manufacturing and a vertical integrated supply chain, we combine innovation, reliability, and the scale to support the AI revolution. Thank you very much.
All right, well, thank you for joining. I'm the next presenter from Amphenol, and today I'd like to give you my perspective of what is it that we're doing that's enabling the next AI innovations. And in one word, it is performance. So what we're seeing out there is this huge drive for performance across all these different connector families that are in storage and server applications. There's way too much to talk about here, but I did put all these in red that are currently in distribution. So a lot of these products we are continuing to do and put into distribution, so they're available through distribution, which is a good thing. But what the challenge is, that's for us and for the companies that we're working for, is to get to the fastest possible systems that they can create. And so that drives some internal design things, but what they look for us for is the next generation or the next speed performance improvement on all of our connectors. And as I showed you, this connector family and the family of connectors that are in the SSSIO business unit are the standards that we find within this this industry. So we've taken the PCIe, the EDSFF, the M.2, and we move them up to a next speed generation. And what we're trying to communicate out there, and what this shows is, here's what's going on right now in these different categories that are pushing the boundaries and moving us into a next generation speeds for our customer to build their next generation products. Last year, we released Gen 5 products, and now we've already tooled up these green items here showing what we've released in Gen 6. And this is what's driving the AI innovation right now. These connectors, and the connectors apply to the SSD form factors. Here's a picture of the EDSFF standard and how many different connectors, configurations, orientations, sizes. So each of these portfolios are large, and we've tooled these up in all the popular sizes right now for Gen 6. And what we're communicating is, for all these form factors, especially the SSD form factors, the EDSFF E1 and the E3, which is just now rolling out more and more, we have next generation connectors and cables for these applications to achieve your highest performance requirements. Here's one example of what we're doing right now. We have our vertical EDSFF connector already tooled for Gen 6, and here's kind of what that looks like. So we have that available. Because Amphenol is a technology leader, we also are working on our next generation Gen 7 products. And we are prepared and already working on concepts for these products as well. So they won't be in distribution, but what this shows is, for all these different form factors, we are working in the future to be able to have this next generation of performance, because what's holding things up is getting more memory and faster memory. We haven't overcome the processor speeds. And so until we reach that parity, we're still pushing for faster and faster data rates. The other thing that is being pushed by AI is the need for more power. This is one of the biggest issues with a data center, getting more power, and that power eventually goes through a connector at some point, a cable or a backplane. So for our different standards in this space, we are now adding another connectors that have power, low power and medium power. Because this is about performance, it's also about density, getting your connections as close to your processors as possible. So right now we are releasing a double density version of our mini cool edge. So this has multiple applications. Right now we have it tooled in a board to board, but we can also do cables, and we're looking at this product as a key product for AI enabling because of its future speeds and because of its high density, get things closer and more dense. What's really driving a lot of what's going on in the AI space right now is memory. And it's about getting faster memory closer to these graphic processor units and these CPUs. So what we're doing for memory is something that the industry is seeing now for the first time, and it's definitely somewhat of a revolution. Right now, the traditional memory has come in a DDR form, and so we have DDR connectors, and we'll continue to have DDR5, and we'll continue to have DDR6. But there's a new memory form now on the market called CAM, and so more and more things will start showing up with CAM. And let me tell you about what's going on with CAM, what it is, and Amphenol is trying to be a leader in that marketplace. So CAM stands for Compression Attached Memory Module, and it is the evolution or a revolutionary design where DDR is very high and tall, CAM is low in its profile. So it is a lot more dense, a lot different memory, and so it's got a density and it's got a proximity advantage to get closer to the processor. And so the industry is moving towards a couple of different form factors for this. You'll hear this and see this more and more. This actually has already been released for applications such as tablets and notebooks. And now there is the LP CAM, which just stands for low profile CAM. That's been released, and there's a couple of different forms of that. And the SO CAM is a new version for storage applications, and it's coming out in different pin sizes. Right now it's in 694 pins. So in the space that you can put DDRs in the 200, 300 range, you can put more density, more pins, and closer to the processors. And that's what's driving the current memory part of the AI revolution. There's one other part. So memory we need as close as possible for the compute side, but all this computing and generation is creating more and more data that needs to get stored. So these data centers are now starting to scale and have the need for storage, and storage in a high capacity, but not in the fastest speed. So another form factor that I believe we're going to start seeing more and more of is the PSAS, or the U.2 form factor. And let me show you what's going on here. The U.2 is merely an extension of the original SATA and SAS connectors. And here you can see that we have U.2 tooled in Gen 5, and the question has been, is anybody going to be able to take the design and create the Gen 6? And so Amphenol, we've done that. We have a design completed. We have parts that are tooled, and we're working with customers on U.2 Gen 6. So we see that form factor coming back for the data centers and the storage applications, and that's going to be a part of the next generation in AI. So I hope that gives you some picture of at least what's going on in the requirements, because all these systems take all these standard form factors. We're going to be at the heart of all that. And we have already invested a lot of money in next generation equipment to be able to support all of our customers out there. So thanks for taking the time to listen, and have a great day.
Awesome. Thank you, everyone. So we will now open for our Q&A portion of the webinar. And I do have some questions. So for Jimmy from Basics, you mentioned that cold plate liquid cooling is the most popular method for servers and switches. How do you see sensor cable technology evolving to meet the increasing demands of AI servers, especially as liquid cooling becomes more widespread?
Okay, thank you, Greta. I think it's miniaturization and direct integration. As cold plates become more complex to handle higher than 1,000 watts chips, real estate is precious. So the first one is we may have microsensors. Microsensors will shrink from discrete components to micro electromechanical systems that can be embedded directly into the cold plate. And the second one, I think, is integrated cabling. Sensor wires will be printed or embedded directly onto flexible substrates like FPC that are part of a cold plate assembly. So reducing the bulk and value points of separated cable. I think that is. Thank you.
Thank you, Jimmy. My next question is for David from High Speed Backplane. Your presentation highlighted the transition from last-gen AI systems with 8 to 16 GPUs to next-gen systems scaling up to over 500 GPUs. What do you see as the biggest technical challenge in ensuring reliable interconnect performance at this scale? And how does high-speed backplane connector technologies address those challenges?
Yeah, great question. So moving from 8 GPUs to more than 500 is not just about adding more cards. The real challenge is to keep every high-speed signal clean and reliable at that scale. At a speed like 112 to 24 gigabits, even a small impedance dump or crosstalk issue can consume the entire link margin. So when you multiply that risk across thousands of links and in a large chassis, loss, scale, and variation become the biggest threats to the system performance. High-speed backplane connectors like XMX and PHD are designed to fight those issues. They provide tight impedance control, ultra low loss performance, better crosstalk. They are also mechanically robust, so SI performance stays stable and when system grow. So our connectors let system designers scale GPU systems with top-end electrical performance. Thank you.
Thank you, David. My next question is for Greg from High Speed I/O Cable Assemblies. You discussed the transition from high-volume passive DACs toward AEC and LPO solutions. What do you see as the biggest technical or cost barriers to accelerating adoption of LPO solutions? And how does high-speed cable assemblies position itself to overcome these challenges compared to other competitors?
Yeah, good question. So I think what I talked about is that the biggest issue is
speed and length and also cost. And so as the DAC cables, copper's been amazing how it's kept up with speeds, but as it continues to keep up with speeds, we need to do more active circuitry in these devices, and so that drives the cost up a little bit. And so what we're doing to kind of keep the performance high, but also keep the cost as low as possible, is we're really working on all of these different technologies, but there's two technologies that are quite interesting. One of those being the ACC, which is a linear amplified DAC cable that keeps the cost down, keeps the latency very low, and allows to get to the longer links. And the other one in the optics area is we're doing more LPO, so linear pluggable optics. And again, it uses, rather than a DSP, it uses a linear device that keeps the power low, keeps the latency low, keeps the cost low also. But at the same time, gets the performance that you need to get these systems to work. And so, we're doing the broad spectrum, supporting them all these different technologies to keep the performance high and the cost as low as possible. But at the same time, really focusing a lot more on those linear devices, both in the copper cable world as well as in the optics world.
Thank you, Greg. My next question is for Angelo from our high-speed I/O connectors business unit. So beyond hyperscale data centers, are you seeing adoption of 112G and 224G connector solutions in edge computing, 5G infrastructure, or ruggedized industrial AI systems? And what unique challenges do those environments present?
Yeah, good question, Greta. So currently the big bulk of the demand for 112 and 224 and beyond are actually from data centers, as mentioned. Obviously, this is driven by applications such as AI training in cloud computing, where these workloads move massive amount of data between each others, like I mentioned. There are some demand in edge computing too, in order to service said data centers. But however, the demand isn't as high yet, since they don't need to process the same amount of data on the same scale. In addition, when you are deployed in a manufacturing facility or a hospital, for example, there's a need for them to be also robust and power efficient. So these are something that these high-speed connectors are not at the moment. On the contrary, 5G telecom and industrial systems are still in its infancy stage in adopting these higher speeds. Similar to the edge computers, these applications often require to themselves to be even more rugged and power and cost efficient. As you can imagine, at the single 5G cell site, only serving up to, I think, 10 to 20 gigabytes per peak traffic, 112 and 224 is considered overkill. And if you're located in a remote area where many of these cell sites are, then the last thing you want to do is constantly spend effort with power cycling and cooling these applications.
Thank you, Angelo. My next question is for David from our Power Solutions business unit. So you highlighted how different connector solutions like Pool Power HD and Barclip are optimized for AI server and GPU applications. How do you see these innovations shaping the design choices of AI data centers over the next 3 to 5 years, especially with the push toward higher density and efficiency?
Yeah, thank you, Greta. So as processing speeds and AI computing power continues to increase, we find there's a correlation to the power increase as well, right? So our R&D team here at the Power Solutions Group is constantly developing new concepts and continues to invest in products that increase power density while maintaining a small, compact footprint, right? So we continue to partner with the key integrators and the OCP community. That's really what drives our designs. So I encourage everyone to reach out if you have any questions about our products or would like to partner on a new design. So reach out directly or check out our webpage for the latest information. Thank you.
Thank you, David. And my last question is for Donald from our SSIO BU. So, from your perspective, which application areas, such as data centers, AI accelerators, or high performance storage, are driving the fastest adoption of Gen 6 ready interconnect solutions? And what's influencing those priorities?
Thank you for the question. And just to put things in some more clear perspective, the business unit that I represent has all the storage standards that are inside the box. Many of these data centers, so much is going between racks and within a rack, and a lot of it is cabling that is the highest speeds they can get for certainly for the AI applications. There are many data set applications that will be more hybrid, where there's a variety of memory and memory speeds, memory costs, all these come into play. So for data centers, it's a little more complex. For the AI accelerators and the highest performing, highest speed performances, um, these are inside the box, and they're heading more towards the CAM applications. And certainly this is where Gen 6 products are in the highest demand to be in the box and running next to these processors. What's kind of influencing those priorities um, is in evolution right now. I think I've been to some recent AI conferences, and you can see the explosion across the industry at all kinds of different levels, enterprise levels, on the edge, AI applications running through phones. Not everything will be processed up to the cloud and returned back. Many things will be processed more locally. And so there's lots of applications. Amphenol has all the Gen 5 products available, and that's going to be, I think, where a lot of our customers are looking for where their applications are. For the highest performance, the highest speed, the AI systems, these require the highest forms and highest speeds. And so we're involved in the standards in all of these, and we are tooling up Gen 6 in many of the primary applications, and we're already starting on Gen 7. So we're excited about the AI revolution. For me personally, it's one of the highlights in my career. I think it's going to be a world kind of changing effect. And so if you're involved, you can be really glad and not fearful. I think there are many good things that are going to happen, and so we're excited, and we're working with all of our customers for all these new applications.
Thank you, Don. That's awesome. And that is all the time that we have left for today. I just want to thank everyone for joining us. And I especially want to thank all of our presenters today for their time and for sharing their latest AI innovation. If you do have any questions about today's presentation, please do not hesitate to reach out. I hope you have a great day.